Hello students, welcome to my class. Today I will teach you periodic table and I will explain the periodic properties and their variations in groups and periods in a periodic table and also explain the reason of periodicity. I'll try to make the concept simple for you to understand it easily. Sorry. And I've taken up topics from your syllabus. So children, please like, share and subscribe my channel and see that you don't hesitate to put your doubts in the comment section and I will clear it, and all the notes will be there in the description box so that it's easy for you to refer. So here are the topics that I am going to cover today. The salient features of the modern periodic table, periodicity, periodic properties and chemical reactivity. Now here we begin. So children, you all had read it last year and must be remembering also the different laws by different scientists like Dobereiner, Stride, Newland's octave, Mendeleev and finally Moseley, who put forward the modern periodic table, that is the tabular way of arranging the elements in groups and periods. Let me remind students, please learn the definitions from the text as I had already told you in my previous videos. And now about the modern periodic table. The salient features of modern periodic table was also done in the previous year, but I am definitely going to revise once regarding what is a group, what is a period, their names and the members, and all that is important from the examination point of view. So first of all, the 18 vertical columns, that is the vertical columns top to bottom, 1, 2, 3, 4, 5, 6 and so on till 18. So all these vertical columns, top to bottom vertical columns, are known as groups. Now the number, that is first group, second group, third group, fourth group and so on, will tell you the number of electrons in the outermost shell. Like the group 1, there is one electron in each of their outermost shell, like hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. They will all have one electron in the outermost orbit. Similarly, group 2, beryllium, magnesium, calcium, strontium, barium, radium, they all have 2 electrons in the outermost orbit. So each number indicates the number of electrons in the outermost orbit. The first one, the group 1, the name is alkali metals. The group 2 is alkaline earth metals. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means 3 to 12 are transition elements. 13, 14, 15, 16, 17 individually are named as boron family, carbon family, nitrogen family, oxygen family, and the 17th one is halogen. The 18th group, this is a zero group or inert gases or noble gases. Now let me tell you one thing, the group 1 and 2 as well as 13, 14, 15, 16, 17, 18, they all have different block elements. 1 and 2 are S block, 13 to 18 are P block, and all these 3 to 12 are D block elements. These are transition elements because they have got 2 outermost shells incomplete. Okay, so this is alkali metals, this is alkaline earth metals, these are transition metals, then boron family, carbon family, nitrogen family, oxygen family, halogen and inert gases. Now here in the 6th period, it is see 57 to 71, this one, the atomic number 57 to 71 are lanthanides, they are rare earth group. Then 89 to 103, these are actinides. These are radioactive in nature. So the sixth group and the sixth period and seventh period. Now I'm just first talking about the groups. Now period, what did I say? These are the horizontal rows. There are 7 horizontal rows. So 1, 2, 3, 4, 5, 6, 7 horizontal rows, and this number represents the number of shells. Like first period, hydrogen and right here helium, they've got 1 shell. The second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they all have 2 shells. Similarly, the number of period indicates the number of shells present in an atom. So the sixth period, as I just named it, these are 57 to 71 lanthanides. The seventh period, 89 to 103 are actinides. Now one more thing which we did it last year was, what is first period? It is the shortest period. Why? Because there are only 2 elements in this period. The second and the third are short periods. There are 8 elements. The fourth and the fifth are long periods. There are 18 elements. And the sixth and the seventh are longest. There are 32 elements. So I think this is what we did it last year, and I revised all of them. Only the properties individually I have not done right now. They are there. So if you want, please refer to the text. And I think I have told all about it. Let's now go to the next slide. That is, the next topic with us is periodicity. Very important definition, as I said, please learn from the text. Periodicity is actually the property that reappears at regular interval, like it increases or decreases as you come down a group or go across a period. Come down a group means from top to bottom. Go across a period means from left to right. So either a property increases down a group or decreases down a group, increases across a period or decreases across a period, or remains same. It varies for different property, as it will say, which we will discuss now along with the reasons. Now what is the reason for periodicity? The cause is the recurrence of similar electronic configuration. That means if 2 elements have got same electronic configuration, definitely they will have same number of electrons in the outermost orbit. So that is the major reason for periodicity. So here I have first taken 2 major things, topics, that is shells and valency, which we did it last year, but as I said, I will revise once again the number of shell. So if I can show you over here, if I come down a group, so I am coming down to from 1 to 2 to 3 to 4 to 5 to 6 to 7. That means every time I am jumping to the next period. So what am I doing? I am increasing each number of shell. And when I am coming down the same group, what is there? Same number of electrons in the outermost orbit. And when you go across a period, that is from left to right, what is happening? It is the same period, so it has that same shell. But every time you go towards the right, the atomic number increases. Therefore, every time there is one increase in number of valence electron. Now let's come back to the topic, that is number of shells. So as I showed you just now, down the group, it increases successively. That means every time by 1. And across a period, it will definitely remain the same. What about the valency? Down a group, it will remain the same as I showed you just now, and across a period it will increase from 1 to 4 and decrease to 1. How? 1 to 4 means atomic number increases. From 4 to 5, atomic number, the valency will now become 3. 6, the valency will be 2. 7, the valency will be 1, and so on. So every time 1 to 4 increase and it decrease to 1. Now let's start with our periodic properties. The first one that we have taken is atomic size. So what is atomic size? It is the distance between the center of the nucleus of an atom and its outermost shell. Please don't learn this exactly, learn what is there in your text, because definitions are important in this chapter along with the factors on which these periodic properties depend, and the trend. So let's begin with atomic size. So as I said, distance between the center of the nucleus of an atom to the outermost shell. So it depends on two major factors. One is number of shells and another is nuclear charge. Now let me explain how. Number of shells. Every time the number of shells increases, the size will increase, because the distance from the center of the nucleus till the last orbit will keep increasing with the increase in the number of shell. What about the nuclear charge? If the nuclear charge increases, that means the positive charge at the center increases, which shows that there is a force of attraction of the electron towards itself with an electrostatic force of attraction, and every time the charge increases, the electron will try coming inside, thus decreasing the size. So with the increase in number of size, the size increases. With the increase in nuclear charge, the size decreases. Now the trend. If we come to the trend, we will see that down a group down a group, the atomic size increases. How? Because every time you come down, the number of shells will increase, but at the same time nuclear charge also increases. Children, there should be a gap over here. Okay, printing mistake, that's okay, which you will get it corrected in the description box. So when you come down, the number of shells increases, and also there is increase in nuclear charge, but the effect of the increase in number of shells overweighs the increase in nuclear charge. Thus the atomic size increases when you come down a group. What happens across a period? The atomic size decreases. How? Because nuclear charge increases every time. As the nuclear charge increases, definitely the size will decrease. Now, if I can take you back to the periodic table, and you see the second period, and the size when you go across a period, the size you said will increase or decrease? Will decrease. So the lithium will have the largest size and fluorine will have the smallest size. What about the third period? Sodium will be the largest and chlorine will be the smallest. But what about this? So I will take you back to that slide where I have written it down for you, easy for you to remember. Second period, lithium has the largest and fluorine has the smallest. We discussed just now. But the inert gas, that is the element next to the halogen, will have a size larger than the halogen. Why? Because of the complete outermost shell. Since the outermost shell of the inert gases are always complete, therefore the size is comparatively larger than the halogen. Okay, so the next comparison is of a cation and one anion from its parent atom. Cation will always be smaller than its parent atom. Why? Because the number of protons are always more. Cation means a positive charge. Positive charge means number of protons are more. When the number of protons are more, definitely the size will be smaller because of the pull. Whereas for an anion, the size is always bigger than the parent atom. How? Because the number of electrons are more. But what happens? If I can give you one example over here for a cation, that is Na plus is smaller than Na, and for an anion Cl minus will be bigger than Cl. But what about if you are comparing many ions, provided all have the same number of electrons? We compare the size depending on the number of protons, which we discussed just now. More the number of proton, what happens? More the number of electrons, what happens? So one of the two, either number of protons or the number of electrons, will have to be same. If all the number of electrons are same, then please compare it with number of protons. There will be example questions in your text, children. I would suggest please go through the questions also. Every time you understand a particular topic, please see the last 10 years question also. That will always help you. Now the next topic, and that is metallic character. So what is a metallic character? What is a metal actually? A metal is one element which has got 1, 2 or 3 electrons in the outermost orbit. Now with those 1, 2 or 3 electrons in the outermost orbit, the atom will definitely have a tendency to lose the electron so as to attain the stability. How attain the stability? That means to complete the outermost shell, that is octet or duplet of the first shell. So the tendency to lose electrons depend on the two factors, that is atomic size and nuclear charge. Now actually what happens is the easier it is to lose an electron, the better metal it is. Now how does these factors vary? Like if the atomic size, now if the atomic size is more, there will be lesser nuclear pull. So easy for a valence electron to be removed, therefore more metallic character. If the nuclear charge is more, there will be more pull by the nucleus or the force exerted by the nucleus, so difficulty to remove the valence electron, therefore less metallic character. Now based on these two, if we come to the variation down a group, actually down a group the metallic character increases. How? Since the atomic size increases and the nuclear charge also increases, but the effect of atomic size, as I said, overpowers the nuclear charge, so the metallic character increases down a group. So in group 1 lithium is the least, but in period 2 lithium is the most. Across the period it decreases. How and why? It decreases across a period because as I said, the nuclear pull increases and the size decreases, therefore the metallic character also decreases. Now there is one factor which I want to discuss over here, is why aren't we considering francium every time in group 1? Because it is radioactive in nature and the properties are very difficult to note down. One more thing I want to say about metal over here is that whenever there is a tendency to lose electron, it is a better reducing agent. So all the metals are good reducing agent. So we come back to, suppose I give you one example over here. If I take up a group, like I just showed you the example of a period. So if I take a group, it is lithium, sodium, potassium, rubidium, caesium, the metallic character increases. So less metallic, more metallic, maximum metallic. When I go across, it is metallic character decreases, so most metallic. This was what I was trying to explain in this part of my explanation. So the next topic, let it be non-metallic character. Here non-metallic character is a tendency to gain electron, like metallic character lose valence electron, this is gain of valence electron. So the tendency to gain electron so as to attain stability or complete the valence shell, that is octet or duplet in the first shell. The tendency to gain electron, and it is non-metallic in character, depends upon atomic size and nuclear charge. Now again, atomic size, smaller the atomic size, greater is the nuclear pull, so tendency to gain electron becomes more, so more non-metallic. Greater the nuclear charge, more tendency to pull the electron, a better non-metal. Now the variation down a group, the non-metallic character decreases, reason atomic size increases and it affects overpowers the nuclear charge, therefore it decreases. Across the period, yes, it increases. About non-metal, if metals are good reducing agent, non-metals are good oxidizing agents because they are going to gain electrons. Now the next topic is chemical reactivity, which is again very important, and to explain this I need to go back to this. Now see, as I told you, the first, the second and the third period, these are metals because 1 electron, 2 electrons and 3 electrons in the outermost orbit. Metal, metal and metal, but the metallic character is decreasing. Here non-metal, 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 but the non-metallic character is increasing, and when we come down the metallic character is increasing, and when we come down this side the non-metallic character is decreasing. So basically what I wanted to tell you is, when we talk about, let me go back to that, when we go back to chemical reactivity, we know that it depends on the tendency to gain or lose electrons. Like greater tendency to gain electron, more reactive. Greater tendency to lose electron, more reactive. Less tendency to gain electron or lose electron, less reactive. That's why I went back to the periodic table to show you. Now, depending on the tendency of gaining or losing electron in the outermost shell, if it decides the reactivity across a period, therefore the chemical reactivity first decreases and then increases. How? I'll go back. First decreases because non-metallic character is decreasing, and then increases because first decreases because metallic character is decreasing. The non-metallic character then increases, so it increases. Therefore, let me repeat, across a period the chemical reactivity first decrease and then increasing. Now in a group, and we all know in a group, when we are talking about the metal, these three, the metallic character is increasing, so definitely the reactivity is also increasing. But when we go to the non-metals, the non-metallic character is decreasing, so the reactivity is also decreasing. So down a group for 1, 2 and 3, reactivity increases. For up to 17, reactivity decreases. Now since I am already there in the modern periodic table, let me tell you that you all have to learn group 1, group 2, group 17 and 0 group. I have already named them: alkali metals, alkaline earth metal, halides, that is halogens, and inert gases. You have to learn all the members of these 4 groups along with their symbols. Periods I am not saying, because 1 to 20 you all had learned it in standard 7, revised in 8 and 9 you were perfect. So 1 to 20, that is first period, second period and third period, it is already learned. Therefore I am not repeating it once again. So we go to the next slide. The next property, that is ionization potential. Now ionization potential is something which is energy required to remove an electron from the neutral gaseous atom to convert into a cation. That means when you remove an electron from the outermost orbit, it gains a positive charge. Positive charge means a formation of a cation. So lesser energy required to form a cation, better metal it is. So lower ionization will make a metal better. So actually it is the energy required to remove an electron to form into a cation. And to remove an electron, the energy level has to be more or less depending upon the type of element, which again depends on 2 factors, that is atomic size and nuclear charge. Now what happens if the atomic size is more? Lesser force of attraction by the nucleus, so less energy will be required for the valence electron to jump out. Therefore it is less ionization energy required to remove the valence electron. If there is a greater nuclear charge, greater force of attraction, so the electron to be removed from the outermost shell will be more difficult, so more ionization energy. Now when we talk about the trend down a group, the ionization energy decreases. Why? The atomic size is more, and the effect of atomic size overcomes the effect of increased nuclear charge. Across a period, the ionization potential, ionization energy, or you can even say ionization enthalpy, increases. Why? The atomic size decreases as well as more nuclear charge. So we can say that helium has the highest ionization energy and caesium has the lowest ionization energy. A metal will always have low ionization energy and a non-metal will always have high ionization energy. The next factor that we are going to, deal is electron affinity. The amount of energy released while converting a neutral gaseous atom into an anion. How? By addition of an electron. So an addition of electron, one electron or two electron, to complete the outermost shell, that is octet or duplet of the first shell, the amount of energy which is released is known as the electron affinity. Now this also again depends upon the two factors: atomic size, nuclear charge. Smaller the atomic size, more attracted by the nucleus, so greater electron affinity. Greater nuclear charge, more attractive force, so a greater electron affinity. Now when we talk about downer group, it decreases. Why? The atomic size is more and it overcomes the effect of nuclear charge, therefore the electron affinity decreases. Across a period, atomic size is less, nuclear charge is more, so definitely it will increase. Now here it is something important, that fluorine has lower electron affinity than chlorine, where it should be more, but it is lower. Even oxygen has lower electron affinity than sulfur. Why? Because fluorine and oxygen has small size, due to which there is a strong inter-electronic repulsion. So the incoming of electron is not very easy. Therefore, this is one exception. Children, please remember, it is important from question paper point of view. Next, and the last topic is, last topic means from your text, okay, according to your syllabus. I am going by your syllabus. So electronegativity, that is the tendency of an atom in a molecule to attract the shared pair of electrons, that is a bond forming electron. Like suppose there are two atoms, they are sharing one pair of electron. The shared pair of electron, instead of being at the center, if it has to be attracted by one of them, then it is more electronegative in nature. Now this also depends on the two factors, atomic size and nuclear charge. Greater size, less electronegativity, since the electrons are at a distance from the nucleus, so less force of attraction. Greater nuclear charge, so greater electronegativity. Why? Greater force of attraction. So if you talk about trend, down a group, it decreases because the effect of greater atomic size overcomes the effect of nuclear charge, and across a period it increases as the nuclear charge is more, and therefore the electronegativity is also more. So children, we have actually discussed and covered all these topics given here: features, periodicity, periodic properties, about chemical reactivity. So please see that you read the chapter, listen to the video, understand the reasons and answer why the reason tend to those change. And I have noted down the properties and how they change across a period and down a group for you. It will become easy, and children, all these will be there in the description box. So see them when you prepare, try to understand, and if you have any doubt, put it in the comment section. I'm going to clear all of them. Do hit the like button, share and subscribe my channel. Hit the bell icon to get notified about my next upcoming video. Okay children, take care. Okay, thank you children, stay tuned.